In this video, let's understand the difference between correlation and covariance. We use the Greek letter ρ to denote correlation of two random variables. See that the formula of correlation is covariance of x and y divided by the square root of variance of x times the variance of y. Therefore, correlation is just the normalization of the covariance. Why we want to normalize the covariance dividing by the square root of the variance of x and y. Let's write the correlation in terms of standard deviation of x and y, because it's easy to see the logic. If you take the square root of the variance of x, we get the standard deviation of x. And if you take the square root of variance of y, we get the standard deviation of y, that is the sigma y. And the sigma xy is the covariance of x and y. See that the unit measure of covariance is the unit measure of x times the unit measure of y. And this is hard to interpret. When we divide by the standard deviation of x, we remove the unit measure of x. And when we divide by the standard deviation of y, we remove the unit measure of y. That means that correlation is a unit-free measure that varies from -1 to 1. Note that covariance can be any positive or negative number, like 1 million minus 1 trillion. Positive correlation means that the variables move in the same direction. For example, if one variable increases, the other increases as well. If one variable decreases, the other decreases as well. Negative correlation indicates that the variables move in different directions. Stocks and gold is a good example. Usually, when the stocks are doing badly, the price of gold is increasing. See that correlation can be zero only when covariance equals zero. The denominator cannot be zero. The division by zero is not defined. When variance equals zero, when you are working with a constant and not a random variable. And by definition, a constant has no variation. That means it does make sense to take the variance of a constant. Therefore, all important information about the linear association between two variables is here in the covariance between x and y. This normalization here is just to help the interpretation.